Hi, my name is Eliza Simondera, and this is my lab report for the 5th lab, which I chose to be about the falling Slinky. The purpose of this lab was to compare the observed and predicted position versus time graph as the Slinky fell. With that being said, the system was the Slinky and the surroundings were everything else, including gravity and air resistance. The concepts that were applied in this lab were Newton's second law of motion, which states that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass, gravitational force, which is the force exerted between two objects pulling them together, and drag force, which is the force exerted on a moving object by surrounding fluid, which in this case is air. The equations used were the gravity force formula, the velocity update formula, the position update formula, and the drag force formula. I found a video of a Slinky that was falling, so performing an experiment was not necessary. I then uploaded the video into the tracker software. Once the axes were set up, I tracked the Slinky's bottom position frame by frame. This resulted in data that I graphed in Excel. I then used GlowScript to create the projected graph with the velocity and position update formulas. To analyze the results, I put GlowScript's data into Excel and combined the graphs. This is the video that was found of the Slinky falling. This is a screenshot of the tracker software that was used to create the position versus time graph. The purple lines are the axes. The red diamonds following the mass's path are the position points. They were recorded frame by frame as the Slinky fell. As you can see on the right, the graph was made in the software and the data points are all below. This is the GlowScript code. As this lab was chosen by me, sample code was not given. I pulled from past labs to set up GlowScript, and then change the starting values and equations. The highlighted boxes are lines that I changed. I modeled the Slinky's path by using two loops. The first loop happens while the Slinky is falling, and the bottom is stationary, while the second loop is when the bottom moves. In the first calculation loop, I calculate the gravity and tension force and combine those for the net force. I then update the mass's velocity and position vectors with the velocity and position update formulas and plot those values. In the second calculation loop, I calculate the gravity and drag force and combine those for the net force. I then update the mass's velocity and position vectors with the velocity and position update formulas and plot those values. I ran the code and this was the model that was projected. The image on the left is the actual model of the bottom of the Slinky falling. The graph on the right is the projected Y position versus time graph. As you can see, the line stays horizontal for just under 6 seconds and then declines linearly. When I combined the two graphs, I noticed that there was little difference between the two models. They follow the same path fairly closely. While the paths are very close, there is still some discrepancy which could be noted to multiple things. First is the drag proportionality constant. This number was found through trial and error, not calculated. This means that it may not be accurate and the predicted path could be wrong. There was also probably human error in the experiment, specifically that the video was hand-tracked, which could lead to some errors in the position points. It was especially difficult near the end when trying to distinguish between the Slinky and the background as it blended in with the grass. The first discussion question I asked is if the bottom of the Slinky is essentially defying gravity by not falling. The Slinky, of course, is not defying gravity, even though it appears to be. While the bottom is unmoving, the Slinky's center of mass is still accelerating downward. The second discussion question imagines if the Slinky wasn't stretched when it was dropped. In the video, the guy held out the Slinky, allowing it to fully stretch before he let go of the top. If he had instead held the Slinky compressed together and then dropped it, the Slinky would fall as a whole like any other object. This is because there would be no tension because the Slinky is already together. Thanks.